The city of Austin has a goal of reaching zero waste by 2040. To support Austin's sustainability effort, our team, GeoNEAS, wants to provide a tool for decision makers to create efficient public policies that help achieve Austin's zero waste target. The tool forecasts waste trends and groups similar waste patterns across the city. So, how does our proposal tackle this objective? First, to forecast waste trends, we decided to focus on curbside collection, and within this category, to predict the load weight of the two most collected waste types, trash and recycling. Based on these variables, we forecast two key metrics for decision makers: total waste and the share of recycling in the total waste. With our main waste data source and external route collection maps, we map the waste route weight loads to census tracts to provide forecasts and insights, not only with waste data, but including socioeconomic variables. To do so, we use different geographical data manipulation techniques such as spatial joins. When analyzing the trends, we realize that the time series becomes very noisy. However, they follow a mid to long-term trend, which we consider to be critical to formulate public policies. Therefore, we focus mostly on predicting trends, where we evidence optimal results. Our forecast includes a probabilistic approach which allows us to have confidence in them. Additionally, we use clustering techniques to create cohorts of similar tracts based on key socioeconomic factors. With these clusters, we aim to facilitate the waste comparative analysis by grouping tracts with similar characteristics. Our final product combines both of these models into an easy-to-use and intuitive platform which facilitates the visualization of our model results. With our tool, the user can 1. Forecast the waste patterns for the next year and plan the resources accordingly, and 2. Ideate more focalized public policies based on tract groups with similar socioeconomic characteristics. To give an example of our tool's potential use, we can improve the recycling behavior per clusters. As you can see in the waste trend insight section, for each cluster we can calculate the tract with the highest recycling share. What if all the tracts in this cluster perform as good as the best recycling tract? With our product, we can forecast the result of doing so. For example, if all the tracts in Austin perform at the highest level of recycling, the city can increase its recycling recollection from 38 to 87,000 pounds on average. Now, how do the decision makers accomplish this? Well, they now have to identify which initiatives are being done differently in the highest recycling tracts. It can be a special community recycling program, an educational campaign, you name it. Either way, we demonstrate here that our product provides a valuable decision-making tool to jumpstart socio-analysis via ML modeling techniques and to create effective public policies for waste reduction in the city of Austin.